I'll tell you why. Opportunity. When I was your age, I heard it knocking.
Hey, Linda. Welcome back.
Hey, Bill, how you doing?
Great. How long have you been gone? Sure been a while, huh?
Yeah, that Tokyo project took a lot longer than we expected. But now I'm back, and I hear there have been some really big changes around here. They told me you'd fill me in.
Well, we're building something a little different around here.
What, another shopping mall? A new office complex?
Nope. New computer system.
Hey, I haven't been gone that long. We're still architects, aren't we?
Oh, yeah. But now, we're building an open systems computing environment. Now, all the different departments have been involved, the MIS, finance, even we architects, to make sure it's the right solution for the company. Designing this system has been a lot like designing a building.
How so?
Well, basically, we're combining new and existing materials, software, hardware, applications, and tying them all together with a communications network. We're building an integrated framework that has both functionality and structural integrity.
I'll admit one thing. It has been tough trying to do business with our old system. I mean, our computers from different vendors couldn't even share data and applications. Our accounting application only ran on obsolete platforms, so we couldn't move it to newer systems.
Well, that's all changed now. Before, it seemed like we were always having to train people. Every time we added a new application, they had to learn a new procedure. But with open systems computing, our users learn it once, then they can use the same commands no matter which system or application they're using.
So what does everyone think about it?
So far, the reaction's been pretty positive. Even that guy over in drafting is always complaining about everything. Seems to like the new system. And I've noticed just about everybody's productivity has improved.
That sounds good for today. But what about when we expand? This system could be as dated as some of those old buildings downtown.
That's the beauty of open systems computing. Because it's based on formal standards, our technology investment is protected, and we can plan for future growth. I mean, is the Parthenon dated?
I got the picture. Bill, I said I got the picture.
Just bear with me for 2 seconds.
Come on, Bill, I'm still on Tokyo time.
Okay. Just remember these 3 things: interoperability, applications portability, user portability. They're the steel and concrete of a successful open systems computing environment. I picked up all this information on this tape on open systems computing. Even it draws the comparison between designing buildings and designing open systems. Do me a favor. Take a few minutes, watch the tape.
If I watch it, will you get off your soapbox?
Absolutely. Got a lot of things to do. Got to send some electronic mail to a client. Got to get some new budget figures down to the project management office. And I got to do a roll-up on that hotel that's under construction. All on our new integrated open system.
Okay, I get the message. I'll watch the tape.
Open systems have to be built. They can't be bought. Like a skyscraper, open systems consist of various elements and materials that all have to work together seamlessly. An architect starts with a blueprint, a plan, which is based on how the building will be used, the surrounding environment, who will reside there, and the materials, tools, and techniques needed for constructing it. An open systems designer works much in the same way. An open systems computing environment has to meet all the business needs of an enterprise now and in the future. It integrates existing hardware and applications with new ones in order to satisfy the ongoing needs of its users. Open systems computing gives organizations a solid foundation for business success in the 1990s.
Now this I can relate to.
The building blocks for any good open system computing environment are interoperability, application portability, and user portability. Interoperability means being able to share data and interact with applications on any computer in the network. Applications portability means designing an application so that it can run on more than one system. And user portability means users already familiar with one system can quickly learn how to use another.
I can see why open systems computing makes a lot of sense, especially for an innovative, fast-growing company like ours.
More and more, users of information technology are turning to open systems computing as a way to integrate their enterprises from the desktop to the data center. Take Lockheed, a leader in the aerospace industry. At its Palo Alto Research Laboratory, an open systems strategy allows for planning for future growth.
Open systems are extremely important to us from several aspects. First of all, we're going to make a very significant investment in our platforms of the future and in our software that we utilize. We recognize that software changes at a rather dramatic pace, and we'd like not to obsolete our investment. And so the aspect of open systems where one can update applications without having to change out the system significantly is an extremely important economic aspect of our consideration on how we go in future computer needs.
The design specs for open systems are called open specifications. These can be anything from standard programming interfaces to standard network protocols to standard user interfaces. An open specification is developed in a cooperative effort between vendors and users. It is not dependent on a single hardware platform or operating system, and it's available to anyone who wants to use it. A number of organizations are involved in developing open system specifications. The International Organization for Standardization, or ISO, is the International Forum for Standards Development. It sponsors the development of many information technology standards on a worldwide basis, including OSI, or Open Systems Interconnect, for multi-vendor computer networking. The IEEE is developing a set of standards known as POSIX. It allows users and conforming applications to move across a wide range of hardware and operating systems. X-Open is a nonprofit consortium of many vendors working to define the X-Open Common Applications Environment for applications portability. Its specifications are outlined in the X-Open Portability Guide. The Open Software Foundation, a nonprofit research and development organization, is working on specifications for an open software environment. Its OSF motif, graphical user interface, has been widely accepted throughout the industry. And there are many other national, regional, and industry-specific groups working to define open standards and specifications. The National Institute of Standards and Technology helps U.S. government agencies become more efficient.
We're directing our efforts toward getting a worldwide consensus on what the underlying services ought to be and how applications programs interface to those services as a basic way of achieving our portability aims. Applications portability is the strategy that we are using to protect our investment in application software.
Another major corporation committing to open systems computing is Contel, a federal systems supplier and the third largest independent telephone company in the U.S. Contel says formal standards are vital, since the company utilizes a wide range of hardware and software platforms.
International standards are very desirable wherever we can use those standards because they're going to give us a broader window of accessible hardware and software platforms that we can use.
Okay. So what are the real business benefits of open systems computing?
When considering open systems computing, you have to look at the bottom line business benefits.
Good point.
These include getting maximum return on your investment and the ability to dedicate your information technology to solving real business problems and gaining competitive advantage.
Contel is in the business of information technology. So we're in the business of using that technology for our own internal purposes as well as providing that technology to our customers. Being in that business, we think that you can apply that technology to a wide scale of applications and provide value added to our customers by using information technologies.
Each of the building blocks, interoperability, applications portability, and user portability, has important benefits which strengthen the open systems computing structure. Interoperability protects your technology investment by allowing different types of systems, those you're already using, as well as those you'll acquire in the future to exchange information in a meaningful way. Applications portability provides faster time to market, cost savings in development, reduced time spent training end users, programmers, and system administrators, more off-the-shelf applications, and investment protection. Applications portability allows you to spend your time running your business instead of porting applications.
You're certainly going to get software development savings through portability. One of the projects that we're working on here at our technology center is called the software reuse. For instance, in the command and control systems area, which Contel builds for its federal systems customers, we now have a library of over 600 C language program modules, and we can build programs out of those at great savings because we don't have to develop new code.
User portability provides substantial savings in retraining users. It makes those users more receptive to learning new applications, since they don't have to start from scratch. Developing your own open systems computing plan is a real challenge. There are numerous standards and many complex issues confronting computer systems users, as well as an endless variety of solutions offered by suppliers.
Any software development organization needs to have carefully controlled software development practices and procedures. Normally this is embedded in the context of a process, a software development process, and a software development environment with tools that facilitate the implementation of that process.
Your ultimate goal should be to define a plan that makes sense for your business. You can look at each step in the plan as a different story of a building.
Hey, just like the man said, build it one level at a time. If one piece doesn't work with all the others, the whole thing could collapse.
Each level relies on the other for support and stability. The first step in the planning process is to determine your business objectives. Decide what business goals you're trying to achieve through your information technology solutions. Look at all the issues, from how important application portability is to specific competitive goals the applications must address. Remember, standards are the key to achieving application portability. You may want to develop the application in a standard programming language, such as Ada, C, Pascal, COBOL, or Fortran. You may also want to look at operating system-related standards, such as POSIX or the X-Open specifications. And you'll want to see if the application requires a graphical user interface. If so, a standard programming interface, such as the X-Window system, should be included. Applications generally require access to information. The SQL, or Structured Query Language standard, a data definition and data manipulation language, allows consistent access to information stored in databases. So this is another standard you might want to include. Communications are important as well. So you'll want to look at standards such as OSI, or Open Systems Interconnect, which address multi-vendor communications. And there are many other areas you'll need to investigate, such as graphics, networking, and systems administration. As you continue this process of carefully documenting your requirements, you'll be able to match existing standards to those needs. This will help you maximize the portability of the application. The profile you develop can become the foundation for your application development and system acquisition. Your applications then become much more portable to other systems, as long as those systems support the same profile of standards. Standards are the foundation for applications portability, interoperability, and user portability. The standards you choose may differ from those of other companies. In fact, your own standards may differ from application to application, but they should still be integrated.
We're looking for uniformity across our company in delivering information. That immediately leads to the necessity for standards, platforms, standards and software, that we can easily interchange information to make it most cost-effective for us to exchange what we need to do our business.
As you get further into this process, you'll probably identify requirements that standards currently cannot meet. Standards may not exist in a certain area, or the standards may not provide all the capabilities you need. It's important to document these non-standard requirements as well. In some cases, your applications may use them, and this may limit the portability of those applications to other platforms. It may come down to a choice between standards and added value. This is a balancing act between portability and functionality. So it's important to choose a platform and vendor that can provide the right mix of standards compliance and value-added features.
Users have to weigh their use of standards against their need for specific functions, and they have to weigh their need for standards by specific functions over time.
Portability is an objective. It's doubtful that we will ever achieve it to a 100% degree, where I will be able to take a specific program that I have and put it on any application platform, in any support environment, etc. So our real objective here is a pragmatic one of reducing, and I believe we can dramatically reduce the effort and cost required in moving an application from one platform to another.
As your business grows and your needs change, you can enhance or modify the profile you've developed, adding applications as your needs dictate. Like a new addition to a building, this will allow you to continue to move your solutions forward to new systems.
One of the biggest threats to the open systems movement is the notion that there is a simple solution, that there's a silver bullet, that there's some mindless thing that one can do to solve all of the problems. The solutions are not simple because problems are not simple.
Pretty impressive. I'm sold. If we weren't already implementing open systems computing, I'd take credit for the whole idea myself. Oh well.
Well, I'm glad you're so enthusiastic, Linda.
But there is one thing I was wondering
What's that?
about this design. Why would you put the pediments over there? I mean, why not put an arch over the entrance and just leave those columns?
Hey, since when did you start giving
Oh,
me...
just trying to see how flexible you'd become with your new emphasis on integration.
Hey, I'm into flexibility and integration in open systems computing, not necessarily in my architectural designs. Though you've got a point.